We're going to continue with a couple more very basic graphs. And again, you can just print out this handout from Canvas if you want the graph grid already set up for these problems. We're relying on our knowledge of the fundamental graphs of sine and cosine that we have to have memorized. That's what's on this yellow card. And to sketch these graphs, we rely on the quadrantal angles, right? Pi over 2, pi, 3 pi over 2, 2 pi, and so on. So let's do a cosine as our first cosine example. And you should not have to set up a table of values each time, but I'm going to do it here. Once you get a hang of this, at least. And I'm going to look at 0, pi over 2, pi, 3 pi over 2, 2 pi. And so we're going to graph y equals 3 cosine x. And from our sine example, I think you know exactly what's going to happen here. Y will be 3 cosine 0. But cosine of 0 is 1, right? So 3 times 1 is 1. We start out with the point 0, 3 on this graph. 3 cosine pi over 2 is 3 times cosine of pi over 2 is 0. So we got to get comfortable with that fact, so we can just observe that this function value is 0. 3 times cosine of pi is negative 1. So we get negative 3 function value. 3 times cosine 3 pi over 2 is 3 times 0, which is 0. 3 times cosine of 2 pi, we've gone through one full cycle, one full period, so we're back to values that match up with 0, right? 3 times 1 is 3. So we have some points to plot here. And so the big difference with cosine is it doesn't start like sine does. Sine starts at 0, 0. Cosine starts away from the origin. In this case, we're moving up 3 units on the y-axis because of the effect of the 3. But at pi over 2, we're back to 0. At pi, we're at negative 3. 3 pi over 2 back to 0. At 2 pi, we're back to 3. So one full period of this cosine graph, we're stretched out here away from the x-axis, but we still get this shape of the cosine wave, and the pattern continues. So I'm not going to keep plugging in. I know at 5 pi over 2 I come back to 0. I know at 3 pi the function value will be negative 3. The graph turns around and continues. If I go in the negative direction, I have got plunged down to 0 at negative pi over 2, and at negative pi, I'll be at negative 3 with the pattern continuing. We can talk about amplitude of a cosine graph also, just like with sine. And here we'd say the amplitude is 3. And let's see, what else? Oh, I want to just add the regular cosine graph. That starts at 1 to 0 to negative 1 at pi to 0 at 3 pi over 2 back up to 1 at 2 pi with that pattern continuing. Just so we see the relationship between 3 cosine x and cosine x. So there's a example where, again, I've sketched what amounts to two full periods. One period is from 0 to 2 pi. In this picture, it's like I put half a period, pi more units on one side, half a period on the other. You could go from 0 to 4 pi to get 2 full periods. You could also go from negative 2 pi to positive 2 pi to get 2 periods. So there are many ways to get 2 periods worth out of a graph. This is just one example. Well, that's not what we want. We want to go to number 4. So we want to graph negative 3 cosine x. And I'm just going to go right ahead and sketch this graph because we know what the cosine graph looks like. You've got to have the cosine graph memorized. Starts out at 1, then to 0, then to negative 1, 0 to 1. as we move through those quadrantal angles. So if I take negative 3 times cosine, at 0, I'm going to get negative 3 times 1, or negative 3. So I start out down here. Pi over 2, I'll be 0. At pi, I'm going to get a positive 3, because negative 3 times negative 1 will give me a positive 3. 3 pi over 2 back to 0. At 2 pi, I'm back to negative 3 on this graph. And I fill in my wave. So notice again, there are all these other values that we don't worry about anymore because we know what the shape is going to turn out to be. And I even know at 5 pi over 2, I'll be to 0, and I know at 3 pi, this graph is going to be back at 3. If I go in a negative direction, I'll be 0 at negative pi over 2, and at negative pi, I'm positive 3. So there's our graph of negative 3 cosine x. One more time, I'm going to fill in the regular function here, the regular cosine function. And I guess I also want to indicate the amplitude here. So even though we have a negative 3 coefficient, when we refer to the amplitude, we call it plus 3, because it's a distance, and it doesn't really tell us whether the coefficient is 3 or negative 3. If someone just tells you the amplitude, you don't know whether the coefficient is 3 or negative 3. All right, so we're going to move on to more complicated situations in the next segment.